In this lesson, we're going to use similar triangles to solve word problems. So there's two different main types of word problems that we're going to look at. The first one we call the sunshine problem, and this is the shadow that gets cast because of some object like a building and the sun that is shining. So in this first question, we have a pole that is 7.6 meters tall, and it is casting a shadow that's 6.1 meters long. And then there's also an office building, and that has a shadow that is 15.8 meters long. And the question that we want to know is, what's the height of the office building? So we have our sun shining, and then we have our building. And because of the building, it's blocking out some of the sun, so we have a shadow that is being cast. And the building is hopefully built at a 90-degree angle to the ground. So the building itself, this is the height that we want to find. We don't know its height. And we do know that 15.8 meters is the length of the shadow. And then we have just a line that we can draw. This is based on the angle of the sun. So the sun is not changing, which means the angle that is created over here between the building and the part of the ground that is not going to be reached by the sun, and therefore the length of the shadow, that is going to be the same for any object in the area at the same time. And then also the fact that we have a 90-degree angle. And once two of our angles are the same, the third will also be the same. So the two triangles we're going to have are going to be similar triangles because all three angles are the same. So the other thing we have is we have a pole that is also creating a 90-degree angle with the ground, and this has a shadow that is 6.1 meters long, and the pole itself is 7.6 meters. So once again, we're going to have the exact same angle being created over here, and that means we have similar triangles. So what we want to solve for is the height. And when we are setting up our proportions, we're always starting with our unknown. So in this case, height is the unknown. Now I'm going to compare the height of the building to the shadow the building creates. And then that is going to be proportional to the height of the flagpole compared to the shadow of the flagpole. So I have building proportions here, pole proportions here, height to shadow, height to shadow. So now at this point, to solve for the height, all we have to do is move this 15.8. Recall that in a fraction, this line means divide, so the opposite of dividing will be to multiply. So the only thing left in front of my equal sign now is the height. I have 7.6 divided by 6.1, and I'm going to move the 15.8 over by multiplying. Order of division and multiplication doesn't matter, so we're just going to plug this into the calculator now. So 7.6 times 15.8 divided by 6.1 equals, or 7.6 divided by 6.1 times 15.8, and that is 19.7 meters. So therefore, the height of the office building is 19.7 meters. Okay, let's do one more question like that. So, Mr. Smith is traveling to Egypt. So we have another sun question. So he's going to visit the pyramids, and he wants to figure out how tall one of the pyramids actually is. So, although a pyramid has a certain shape like this, if we're looking from the side, that part doesn't matter to us. We're only going to be looking at this part of that triangle. So this part of the pyramid doesn't actually matter. So as we draw our pyramid, the height of the pyramid is the only part that we're concerned about. So that's what he wants to figure out, how tall or the height of the pyramid. and the shadow that gets cast by the pyramid is 4 meters. So the pyramid casts a shadow that is 294 meters. I jumped down to the end of the question. So then at the same time, there is a 2-meter stick that casts a shadow that is 4 meters long. So the height of the stick is 2 meters and it creates a shadow that's 4 meters. So how tall is the pyramid? So this time I'm going to do the height of the pyramid to the height of the meter stick is equal to the shadow of the pyramid to the shadow of the meter stick. To isolate the height and solve for it, I need to move the 2 over. So height is equal to 294 divided by 4 times 2. And that is equal to 147 meters. So, therefore, the pyramid is 147 meters tall. Okay, so that is one type of question where we have a shadow being cast by the sun. We have one object that is a taller object that we cannot just grab a tape measure or meter stick or something to measure it. And then we have another object that we are able to measure the height of. We can measure the shadows created by both, and then we can use that information and the fact that we have similar triangles to solve for a height of an unknown. The next type of question we're going to look at, these are called reflection problems because we have a mirror and there's going to be a reflection happening. So Mr. Smith wants to create a scale model of his cottage, but after traveling 4 hours to get there, he realizes that he forgot the ladder. So remember his similar triangles training, he takes a mirror and places it 12 meters from the base of the cottage. He walks backwards away from the mirror until he can see the whole cottage in the mirror, which happens 2 meters from the mirror. So if Mr. Smith is 1.7 meters tall, how tall is the cottage? So he needs to figure out how tall the cottage is to make his model. So we have here the cottage. So this is the height of the cottage. And this is what he wants to figure out. How tall is the cottage? And then he places a mirror 12 meters from the base of the cottage. So here's where the mirror gets placed. So that's 12 meters away. And then from that mirror point, he is 2 meters away. And he is 1.7 meters tall. So we're going to assume that 1.7 is his eye. So there's his eye, and he's seeing a ray of light that's getting reflected in the mirror from the top of the cottage. So here are the similar triangles that we have created. So we have a proportionality between the distances from the mirrors and then the heights of Mr. Smith and the cottage. So here we're going to take the height of the cottage compared to the distance from the mirror, and then we're going to take the height of Mr. Smith and his distance from the mirror. And we don't need to put units in over here. So to solve for his height, we need to isolate the height by moving that 12. So height is equal to 1.7 divided by 2 times 12, and that is equal to 10.2. So therefore, the cottage is 10.2 meters tall. Okay, we'll do one more question like that. So we have a stray cat climbs a huge pine tree all the way to the top. So we have a tree here. The fire department wants to send a truck to the rescue, but they're not sure how tall the tree is. So a local teen takes a mirror from her purse and puts it on the ground 40 meters away from the tree. So there's our mirror. It's 40 meters away from the tree. So we've got a right angle here, and we want to know the height of the tree. And then that teen walks 1.4 meters away, and she can see the whole tree in the mirror, and she is 1.6 meters tall. So once again, here's her eye, and so the reflection is bouncing into her eye from the top of the tree, from that mirror that is over here. And because the angles here are equal, so if you recall from your grade 10 science, that the angle of incidence is equal to the angle of reflection. So we also have 90-degree angles, and once two angles are the same, the third is the same. So these are similar triangles. So how tall is the tree? The height of the tree compared to its distance from the mirror is the same as the height of the teen compared to her distance from the mirror. So we are going to move the 40 over. So height is equal to 1.6 divided by 1.4 times 40, and that is equal to 45.7. So therefore, the tree is 45.7 meters tall.